Can you hear me now? And what about now? Can you hear me now? Okay, what's going on? Is this just an area of bad reception? No, your reception is just fine. What you're experiencing is sound attenuation, the loss of energy from sound waves. Basically, attenuation is a damping of sound, an interruption that diminishes the volume and quality of the sound wave. Ever notice how you can always hear your upstairs neighbor's dog barking, but the person on the other side of the apartment can't make out what you're yelling? Why is that? It's because sound waves interact with different objects in different ways, and sound quality is reduced more by some objects than others. Here, let's explore this idea a little more closely. How's that sound? Let's start by talking about sound itself. What is sound? In technical terms, sound is the transfer of energy created by vibrations that travel through space. Snap your fingers. That motion creates a vibration, the energy of which rapidly expands outwards. Now, sound travels in a specific pattern of repetitive highs and lows based around a consistent center called an oscillation. That's an oscillating pattern. This oscillating pattern is called a wave. If you toss a pebble into still water, you'll notice ripples, waves created by an oscillating pattern. Sound works in the exact same way. Sound is created by oscillation of waves. So that means that attenuation, the damping of sound, comes from interrupting these waves. Now, sound is energy, so in a perfect environment, the oscillation of sound would only lessen naturally over space as the energy was depleted. Sound waves can only travel so far. But we're very rarely in such a perfect environment. More often, there are other objects around us, so sound waves will be interacting with more complex substances than just air. There are two major ways that objects can impact the oscillation of sound waves and cause attenuation. First, let's look at absorption, the process of transferring the energy within sound waves into another object. Watch what happens when you shout at this wall. All of the sound waves hit the wall, but not all of them made it through. Why? Because some of the energy from the sound wave was absorbed into the wall itself. Remember that sound is energy, which means that when this wave of energy hits this solid object at the speed of sound, some of that energy is transformed into heat and transmitted into the object. The thickness, composition, and other acoustic qualities of the object will determine how much sound makes it through and how much is absorbed as heat. This can occur with any substance, from solids to liquids to gases, and each will react differently to sound. The other factor in attenuation is the disruption of oscillating waves through scattering, or reflection. Scattering occurs when a wave is forced to change direction. We hear this as an echo. Shout at the wall again. Now, some of the sound will be absorbed by the wall, some of it will pass through, but some of it will also bounce off the wall, being reflected by the properties of this solid object and scatter in multiple directions. Echoes are much weaker than the original sound because they only represent a fraction of the original energy, that which is reflected and scattered off of another substance. Like absorption, scattering will change drastically with different materials. Your shag carpet will absorb more and reflect less sound than the plaster wall. But in almost all cases, attenuation is a combination of these two forces to different degrees of damping. So, do you feel like you've got a better grasp on attenuation now? Yeah, sounds like it. Technically, sound is a transfer of energy created by vibrations that travel through space. Sound travels in an oscillation, or pattern of repetitive highs and lows based around a consistent center, which creates a sound wave. When this oscillating pattern is interrupted, energy is lost from the sound waves, which we call sound attenuation. Attenuation can happen as sound waves naturally lose energy over distance, or from directly interrupting the oscillation of the waves. This could be a result of absorption, the process of transferring the energy within sound waves into another object, or scattering, which occurs when a wave is forced to change direction. Sound waves will interact with different substances and objects in different ways, but attenuation will generally come from a combination of these factors. So now you know exactly why sometimes you can, and sometimes you can't, hear me now.